Hello everyone. This video is on the Knewton Alta assignment, section 3.2, part 1, called Domain and Range of Functions. So in this video I'm going to be going over a preview version of this particular assignment. So please understand that the questions I see in this video may or may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, so the questions are similar enough. I'm hoping that watching me do this stuff here will help you out in some way when you work on it on your own. Okay, so you got the assignment page here. This is the title is going to be up here, the mastery bar. You have your objectives. Looks like there are 2 objectives for this particular assignment. And then beneath the current objective there should be a question related to it. And then at the bottom of each question you should see a feedback button. Send feedback to Knewton if you wish. You will not have the instructor cheat button, but you will have the more instruction button, which you can click on if you're struggling with a particular topic. It'll take you to a page with further reading or videos or both, and then you'll be given questions related to that instruction, and you can work through the assignment that way if you wish. Pardon me. Alright, so this objective is find the domain and range of a function defined by a graph. Alright. So I'm going to just draw this first one, just a rough sketch of it on a piece of paper, and we'll talk about the domain and range, and we're going to be asked to write the domain and range in interval notation as well. So here it is, a very rough sketch of the drawing they gave us. Now we're asked to state the domain. Now this is a function, right? This graph represents a function. It passes the vertical line test, right? And hopefully you recall from previous videos that the domain of a relation and also a function, right? A function is just a special kind of relation. This is just the set of all the inputs, right? Which in this case would be all the x-coordinates that are used in this particular graph. So I just labeled some important numbers on the axes here. So when you're talking about the domain of a function, right, what x-coordinates are used in the ordered pairs and on all the points on the graph, look at the x-axis and go left to right, right, go low to high, especially because we're going to be writing this in interval notation. So you see how if I go from left to right here, all these x values are used at some point, right? Because this is going to the left forever. I mean, it looks very slight, but it is going this way, forever. So it's going to, the graph is going to the left forever, meaning that every value, from negative infinity on the x-axis all the way up to, looks like positive 3 is used as an x-coordinate somewhere. So I'm starting from negative infinity. Again, every single x-coordinate, every single value on the x-axis is used in some point, right? This x value is used here at that point. The x value of 1 is used here. The x value of 2 is used here. The x value of 3 is used here, right? Now notice this is not an arrow. It's just a solid point. It's just it's like where the graph stops. So from negative infinity up to positive 3, we have values that are in the domain of this function that are actually used as x-coordinates. Then after 3, there's nothing, right? There's x value of 4, that value is not an x value for any point on this graph. Right, anything beyond 3 is not used. So I got from negative infinity up to 3. And remember how the interval notation works. Always parentheses on the infinities, because those are not numbers. And then is 3 actually part of the domain? Well, yeah. See, this point here is the point 3 comma negative 4. It's solid, meaning that it's actually there. So x equals 3 is used here, right? The x value of 3 is an input, is an x coordinate. So because it is in the set, I'm going to put the rectangular bracket on it, not a parentheses. All right, so there's the domain of this function, again in interval notation. And then we do the same thing for the range, but just going up the y-axis instead. Right, remember, the range is the set of all the outputs, which in most cases, as is the case here, going to be y-coordinates. Right, all the second coordinates of the points. So for the range, you're looking at the y-axis values, which ones are actually used as y-coordinates in points on this graph. And you go from the bottom up, right? You go from low numbers to high numbers again, if you're writing things in interval notation. Now once again, I notice, again, there was this arrow over here. It's going down forever. Not just to the left forever, but it's also going down forever. So on the y-axis, this y value is used, this y value is used here, this y value is used here, this y value is used here. Right? Every y value going down forever, right, to negative infinity. Right, from negative infinity all the way up to, it looks like 3 again. Looks like from negative infinity on the y-axis up to 3. Looks like all those y-coordinates are used. So from negative infinity up to 3. Right, and again, you go low to high, always with interval notation. And then you see above 3, there are no points that those y values are used in. Right. So from negative infinity up to 3, and then you got parentheses always on the infinities. And again, 3 looks like it is used, right? This is the point 1, 3 here. 3 is used as a y-coordinate. 3 is in the range. So once again, a bracket. Right. So it looks like they have the same set of numbers, both the domain and range here. So again, you're just looking at different stuff though. For domain, you're looking along the x-axis, what values are used in the points on the graph. And for the range, you're looking up the y-axis and say what values are used in points on the graph. All right, and these are what I'll type in, right? The interval notation for the domain and range here. So back on the assignment, domain, right? You got left parentheses, then negative infinity, comma 3, and then bracket. And you can type these in. You don't need to use these if you don't want to. And the same thing for the range, right? Going up the y-axis, the values from negative infinity up to 3 were used as y-coordinates. And bracket on the 3. All right, great, and that should be good. And then you hit submit. And it'll tell you after you submit if you're right or you're wrong, and then give you some sort of answer explanation. All right, please read through the answer explanations. Right, make sure you understand why you were right, why you were wrong, and hopefully you'll learn from mistakes for the future. Okay, next question. All right, so here we're on the other objective. Find the domain of a function defined by an equation. All right, so notice it's just the domain. And remember, the domain is the set of all the inputs. Right? All right, so I'll write this function out here, and then just discuss with you a little bit, talk with you a little bit about what you're looking out for when finding the domain of a function based on its equation. Alright, so this function here is f of x equals, the square root of 5x minus 15. Right. So the inputs are values of x here. Remember how function notation works, right? The name of the function is f, the input variable is called x, the input values are x, and then the output is f of x, and then over here is how you calculate the output. Well, we just want the set of x values that can be used here. And really, we're talking about, the domain in such a way. So it's the set of x values that can be used, right? Set of inputs that give you a real number output. The set of inputs that yield a real number output. Now the reason we want real number outputs is because we want to talk about the graphs of these things as well. And when you're graphing on the xy plane, the x-axis and y-axis represent real numbers only, no imaginaries, right? Okay, so the set of inputs that yield a real number output. Alright, so some things to keep note of. One, you can't divide by 0. Right, division by 0 is undefined, will not yield a real number output. So if you notice any denominators with variables, you might want to check, are there any values that make a denominator 0? Right, because if you ever have a denominator of 0, that's not good. Right, that's undefined. You're not going to get a real number output. And the only other thing you really need to look out for in this section, this will get added on to later when we talk about logarithms, things called logarithms. But for right now, you just have to worry about these two things. You can't divide by 0. And, even roots of negative numbers are not real. When I say even roots, I mean square roots, fourth roots, sixth roots, and so on. Even roots of negative numbers are imaginary, right? They are not real. So remember, I want to find the values that I can plug in to give me a real number output, not something that's non-real. So here I see an even root, right? A square root. So I would like the expression inside, right? This thing called the radicand, right? This 5x minus 15. I don't want this to be negative. I'm going to say this can't be negative. So I need to find values of x that ensure this is not negative. So this 5x minus 15, right, now to say something can't be negative means it has to be greater than or equal to 0. So you're setting up this inequality here when talking about even roots. You have the radicand is greater than or equal to 0, right? Because if it were less than 0, that would be bad, right? You'd have a non-real output. And you solve this, and then basically you're describing the domain. So 5x then must be greater than or equal to 15, and then dividing by positive 5. X must be greater than or equal to 3. And here you go. There's a description of your domain, all the values you can plug in and still get a real number output. Right? If you plug in 3, you'll get an output of 0. If you plug in 4, you'll get the square root of 5 as an output, and so on, right? All these inputs here will give me a non-negative number inside the square root, and so I'll have a real number output. Now in interval notation, right, they asked us for the interval notation, the domain of this function, you know, the numbers greater than 3 or equal to 3, that's from 3 to infinity then, right? All the numbers greater than 3, parentheses on infinity always, or equal to 3, right? 3 is allowed to be plugged in here. As I said, if you plug in 3, you'll get an output of 0. That's okay. And that's all we want. Right? That's all they're asking us for. But yeah, just keep these in mind here. Right? That you can't divide by 0. So if you have a denominator with a variable, just, you know, figure out the values that'll make the denominator 0 and then get rid of those, right? Those values won't be in the domain. And if you have an even root with a variable expression in it, like this, square root, the expression inside should be, you know, greater than or equal to 0. Can't be negative. Alright. So back here, again, the interval notation we're asked to enter, right? It's a left bracket, 3 comma infinity, and then a parentheses. Those are all the values I can plug in for x and get a real number output. Great, and please read through the answer explanations. Alright, so we're back to finding the domain and range of a function defined by a graph. So here we have a graph. Now pay attention, notice how on the ends here there aren't any arrows, right? So the graph's not going up or down forever. It's starting here at this point, and it's a solid point, meaning that it's actually there. And it goes, you know, left to right like this, and ends here. But notice that this point is open, it is empty. When you see an open or empty point, that means it's not really there. The graph ends there, but that point is not really there, so just pay attention. Alright, so domain, I'm looking left to right on the x-axis. It looks like the graph starts at -6, and that's actually used, right? That point's actually there. And the graph goes. There's a whole bunch of points corresponding to these x values here, all the way up until when x equals 4. But notice, when x is 4, that point is missing. So from -6 to 4, including 6, but not including 4. That's the domain. Right? So bracket on the -6, comma 4, but parentheses on the 4. All right. And then for the range, I'm going from bottom up, looking along the y-axis. And if I go from the bottom up, the graph starts at -5 here. Looks like that point's actually there. So -5 included. And then all the values from -5 up to 4, all those y-coordinates are in some point. Now I know you might be thinking, what about -1? There's an open point there. Yeah, but there's 2 solid points. There are points with a y-coordinate of -1. So from -5 up to 4, including both those ends, make up the range. All right, so bracket -5, comma, up to 4, and then a bracket again, because both of those values are used as y coordinates in some points on this graph. Okay, wonderful. And just pay attention to if there are arrows or solid points or open points at the ends of these things. Okay, great. Alright, now we're back to an equation. So this kind of combines the two things I was talking about. You have a denominator with a variable expression, and you also have a square root, an even root, with a variable expression in the radicand. So we have to kind of combine these restrictions. So I'll write this one out. So we're given f of x equals 1 over the square root of 11x minus 22. So the first thing is, denominators cannot be equal to 0. So you got to think, when is the denominator equal to 0? And then we're going to eliminate that value. So when is the square root of 11x minus 22, when is this equal to 0? And you solve this radical equation here. Square both sides. You'd have 11x minus 22 is equal to 0. Then x must be 2 here. Right? Add 22 divided by 11. So this tells me that x cannot be 2. I hope you understand that, right? Because if x were 2, you'd have a denominator of 0, 1 divided by 0, and that's not real. That's not even a defined value. But then we're going to combine this with, right, do the intersection with, and, right, and at the same time, the radicand, this is again another fancy word for the expression underneath the square root, has to be greater than or equal to 0. It can't be negative, because even roots of negative numbers aren't real. So this 11x minus 22 must be greater than or equal to 0. Then solving this, we get x is greater than or equal to 2. So x must be greater than or equal to 2, and at the same time, not 2. So if you put those statements together, must be greater than or equal to 2, but not 2, that just gets rid of the equal sign and the inequality. So x must be strictly greater than 2. There's a description of the domain of this function. All the values of x that you can actually plug in and get a real number output. So all the numbers greater than 2, but not 2 itself. Right? And if you're talking interval notation, right, the domain of this function is, all the numbers greater than 2, so from 2 to infinity, but not 2 itself, right? So parentheses on the 2. There you go. Okay. But yeah, so be careful. Sometimes you might have to combine statements to make your final domain, right? I hope that made sense. All right, so we got parentheses 2, comma, infinity, and then parentheses again, right? I think it said, yeah, interval notation. Good, just read your instructions. All right. Great, and again, it'll go through all that. Now, they just kind of combine it right away, saying that that radicand can't be 0, because then you'd have the square root of 0 in the denominator, which would be bad. So they put it together immediately. Okay. So here we have another, just find the domain. So again, I'll write this function out. And yeah, notice there's a denominator with some variable expression in it. So I just need to figure out where is the denominator going to be 0. And then we don't use those values. All right. Okay. So we have f of x equals negative 11x plus 1 divided by negative 30 x squared minus 25x plus 5. And again, I'm really only, if I'm talking about domain, and what, now the question is, they're asking us to determine the values for which this expression is undefined, right? So basically, where is the denominator equal to 0? Right, because this is bad, right? So we're solving, this quadratic equation here. When is negative 30x squared minus 25x plus 5? When is that equal to 0? Now, one thing I'm noticing here, that all the coefficients over here are multiples of 5 or negative 5 even. So I'm going to divide through by negative 5. I'll just write divided by negative 5 over here. And that'll make this 6x squared plus 5x, and then minus 1, and then 0 divided by any non-zero number is still 0. Alright, then we have this to solve. Now you can use the quadratic formula, completing the square method, or if it's factorable, you can factor it, which this one is. This would factor to 6x x, and then we'd have to have plus 1 here, minus 1 here. 6x minus 1 times x plus 1 would give me that polynomial there, 6x squared plus 5x minus 1. And then by the zero product property, x would have to be either 1/6, that makes this factor 0, or -1. Alright, so these are the values x can't be. Alright, so I'll make that clear. X can't be this value, x can't be that value, because that'll make the denominator 0. And if you were writing out the domain, the domain would be every number but these. So from -infinity up to -1, or, right, and then union with for the break, a break or a hole, and then from -1 to positive 1/6, those values are good except -1 and positive 1/6, or, and then from 1/6 to infinity, right? This would be the domain of the function, written in interval notation, but they're not asking for all that. They're just asking for the values that'll make this undefined, which are positive 1/6 and -1. Right? So what makes the denominator 0? Right? And they said, just enter your answers separated by commas. So 1/6, comma, -1. Those are the two values that make this undefined, that couldn't be used, that wouldn't be in the domain. Great. Okay. Alright, so now we're still on the equation part. Alright, so I've done 3 of these. Just remember that denominator can't be 0, so x can't be 2 again. Because if x were 2, you'd have the square root of 0 down here, which would be 0, and that's bad. So x can't be 2, and 8x minus 16 has to be positive, right? Meaning x has to be greater than 2. So basically putting that, x has to be greater than 2. Right? Again, you can write all that out, put it all together, but that's from 2 to infinity, right? Without 2, right? X cannot be 2. Has to be strictly greater than 2, so parentheses on the 2. Great. Alright. And then the final one should be back on those graphs, which I think are the easier ones. Now pay attention, right? This is an arrow here, meaning it's going to the left and down forever, right? It's pointing in that direction forever, left and down. So for the domain, again, I know I don't see the graph, but the arrow is there, implying the graph goes to the left and down forever. So every value from -infinity up to 4 on the x-axis is used as an x-coordinate in this graph, and that's a solid point there at 4. Right? So from -infinity up to 4, so parentheses, -infinity, comma 4, and then a bracket, there's the domain. And then for the range, again, I know you don't see graph down here, but the arrow implies it goes down forever. So every y value from -infinity all the way up to 3 is used, right? At the top here is 3. So -infinity to 3 is the range, right? -infinity, comma 3, and then a bracket on the 3, right? 3 is actually the y coordinate of this point here. And that should be good for the domain and range of the function represented by that graph. And I feel this is simple. Just look at the thing and just understand, pay attention to if there are arrows, solid points, open points at certain times. And then one final question like this. Alright, now you see the open point there. So remember, open point means it's not there. So looking at the x-axis, this starts at -1, but it's not actually there, so I'll put a parentheses on -1, and then goes to the right forever, right? The arrow implies it goes up and to the right forever. So from -1 to infinity, those x values are being used in points on this graph. But parentheses on the -1 though, right? That is an open point. So -1 comma infinity for the domain. And then for the range, again, I'm looking up the y-axis. Looks like it starts at -5, but again, that's an open point. So not there. I'll put parentheses on -5. And then every value above that is used, right? The graph is going up forever, and there's no gaps or breaks in the graph after -5, right? So from -5 up, -5 to positive infinity, again, parentheses on the -5 though. So -5 comma infinity, parentheses on both those, and there we go. That should be it. Great. Okay, so again, I really feel, especially these ones with the graphs, stating the domain and the range should be simple. And, yeah. And that should be it for the preview version of this assignment. As I said at the top of the video, please know that the questions I saw here may not be the same questions that you see when you're working on the assignment yourself. But the objectives are the same, right? So the questions should be similar, and the way you work on them should be similar. So I'm hoping that watching me go over these here helps you out in some way when you're asked to do the assignment yourself. And thank you very much for watching.